For the longest time when we talked about AI, it kind of felt like talking to a really, really smart database, didn't it?
Yeah, totally.
You could ask it anything, get brilliant info back, maybe even some creative writing, but it couldn't, do anything with it.
Right. It was all talk, no action, basically.
Yeah.
Like having this amazing advisor who couldn't actually pick up the phone or, send an email for you.
Exactly. And that disconnect, that gap between the smarts and the doing, that feels like what's changing now.
It really is. And that's what our sources are digging into, this shift where AI isn't just understanding or generating text, it's actually starting to act.
Yeah, it's the move from just an intelligent assistant to a proper intelligent agent, something that can see what's going on, reason about it, make a plan, and then, crucially, carry it out.
And this whole transformation, it's happening because of this really powerful combination, this convergence of AI agents and large language models, LLMs.
Okay, so that's what this deep dive is all about then, unpacking that convergence.
Exactly. We're going to look at AI agents, what they are, LLMs, what they bring to the table, and, why putting them together is such a big deal.
And where we're seeing it already.
Yeah, where it's actually working in the real world. And we'll also peek under the hood a bit, see how developers are building these systems right now using specific tools and frameworks.
Okay.
And importantly, we've got to grapple with the big questions too, the ethical side, the practical challenges that come up when these things get more capable, more autonomous.
Right, because that's always part of the story with powerful tech. And we've got a good mix of sources to draw on for this.
We do. It's a real stack, academic papers, digging into the concepts, practical developer guides, industry reports looking at implementations, even walkthroughs of specific platforms. So a pretty well-rounded view.
Good. Because understanding this convergence, it feels key to grasping where AI is actually headed, doesn't it? Beyond just chatbots, how it's going to interact with us, automate stuff, maybe even reshape whole industries.
Absolutely. This isn't just for the tech folks. It impacts, potentially everyone.
Yeah.
So hopefully some aha moments ahead for you listening.
All right, let's get into it then. Where do we start? The core ideas.
Yeah, let's break down the two main pieces first. So AI agents. Let's put aside the sci-fi robots for a moment.
Okay.
In this context, think of them more like goal-oriented software entities. They're designed to perceive their environment that could be reading data, monitoring sensors, understanding inputs online.
So they take information in.
Right. And based on that input, they make decisions, they figure out a sequence of steps, a plan, and then they execute actions to hit a specific goal. These actions could be digital, like sending an email, or potentially physical, controlling a device. They're the doers.
Got it. Goal-oriented doers. Okay, so that's the agent side. And the LLMs, we've talked about them a lot before, but remind us what their role is here.
So the LLM is kind of like the agent's advanced language and reasoning center, trained on just immense amounts of text data. They're incredible at understanding and generating language that feels, human.
Right. Processing instructions, understanding context.
Exactly. They can grasp complex, nuanced requests, reason through problems if you explain them in words, and then generate really coherent and relevant text outputs.
Okay, so we have the doer, the agent, and the understander communicator, the LLM. Why is putting them together so synergistic? What's the magic there?
This is where it gets really transformative.
Yeah.
Basically, the LLM gives the agent superpowers in understanding. Before LLMs, agents often needed really strict rules or very structured data to work.
Right, very programmed.
Yeah. But now, an LLM allows an agent to understand something complex and fuzzy, like, hey, can you reschedule my 2 p.m. meeting with the design team? Looks like there's a massive storm rolling in this afternoon.
Okay, so the LLM can parse that natural language request, understand the intent, the context of the storm?
Exactly. It provides that sophisticated language understanding and reasoning that's needed to even figure out what needs to be done and maybe how. It helps formulate the plan.
And then the agent?
The agent takes that understanding and acts on it. That's the crucial part the LLM can't do alone. The LLM understands the meeting storm situation. The agent, using its available tools, maybe a calendar API, a weather API, actually executes the steps.
Like check the weather forecast, find the meeting invite, draft a rescheduling email, maybe check calendars for a new slot, send it off.
Precisely. And it might even report back that the task is done. It turns the LLM from this, brilliant but ultimately passive text machine into the intelligent engine driving an active problem-solving system.
So it really is moving from what should I do to, okay, I'm doing that for you now.
That's a perfect way to sum it up.
And you said we're already seeing this pop up in different fields. It's not just theoretical.
Oh yeah, definitely not. just theory anymore. Our sources point to quite a few real-world examples. Take the legal sector. Agents powered by LLMs are starting to automate certain workflows. Things like analyzing huge volumes of contracts or case documents, helping draft standard legal paperwork. It frees up lawyers for the really high-level strategy stuff.
Makes sense. Big efficiency boost there. What about healthcare?
Similar themes. We're seeing them used to help analyze patient data trends, streamline admin tasks like appointment scheduling, which can be a real headache, and even assist in processing medical research to support diagnostics. Again, it's often about augmenting the human experts, making things run smoother.
And you mentioned autonomous systems becoming more capable.
Yeah, think about agents that can perform tasks like making online purchases based on criteria you give them. Find me the best deal on these specific running shoes in my size, or managing complex scheduling across different calendars and platforms. The LLM's ability to handle nuance and multiple steps makes this more feasible.
I can definitely see the appeal in finance, too. Analyzing complex financial reports, maybe flagging anomalies that could suggest fraud.
Exactly. Or automating repetitive but critical tasks like data entry or generating financial summaries. Precision is key there, and these systems can help reduce manual errors.
So lots of efficiency and automation potential.
And beyond those, sources mention applications in education, personalized learning paths, tailored feedback, or in customer service, handling more complex queries with, more empathy than older bots. Even in science, helping plan experiments or analyze results. The common thread is that LLM understanding driving agent action.
Okay, so we get the what and the where. Let's peek under the hood now. How does this integration actually function? What are the mechanisms?
Well, at a high level, you can think of it as a kind of continuous loop. It starts with the agent perceiving. It gathers input, maybe a user types a request, or it gets data from a sensor or another system.
Okay, step one, get information.
Right. Then, that input needs to be processed. This is often where the LLM comes in heavily, to interpret and understand the meaning, especially of its natural language, or to make sense of the context of the data.
So the LLM deciphers the input.
Precisely. Then, based on that understanding, the LLM assists the agent with decision-making and planning. It might brainstorm options, predict what might happen if the agent does X versus Y, and help map out the sequence of actions needed to reach the goal.
Okay, so LLM helps make the plan, and then
the agent takes that plan and executes the actions. It uses its tools or capabilities to interact with the digital or physical world.
But it's not just fire and forget, right?
You said a loop.
Exactly, because the agent's actions might change the environment, or maybe it doesn't get the expected result. That new information feeds back into the perception stage. The LLM helps reevaluate, adapt the plan, maybe choose a different action. It's this dynamic adaptive cycle.
And this whole cycle, it's getting easier for developers to build because of specific frameworks and APIs. You mentioned Mistral AI earlier.
Yes, exactly. Companies like Mistral are releasing tools, APIs specifically designed to help build these agentic systems. They provide some really crucial building blocks.
Like what? What makes building agents easier with these tools? Well, one absolutely key feature mentioned in several sources is persistent memory.
Ah, right. This tackles that feeling of talking to an AI with amnesia, where it forgets everything from one sentence to the next.
Exactly. Persistent memory allows an agent to remember context, not just within a single interaction, but across a whole conversation, maybe even over days or weeks. It builds up a history.
That sounds fundamental for anything complex, like talking to someone who actually remembers what you discussed last time.
It completely changes the game for ongoing tasks or building any kind of personalized interaction. Some frameworks even let developers, like branch conversations, explore different paths based on remembered context.
Okay, memory is huge. What else do these frameworks offer?
Access to built-in tools and connectors. This is another critical piece. The LLM can figure out what needs to be done in principle, but it needs tools to actually do things in the digital world.
So giving the agent senses and hands, essentially, beyond just language.
Yeah, that's a great analogy. And the sources highlight some really powerful examples of these tools. First up, and maybe most obviously, web search.
Okay, so the agent can Google things.
Basically, yes. And this is vital because it connects the agent to real-time current information. It's not limited by when its underlying LLM was last trained.
Right, because that training data can be months or even years old.
Exactly. And the difference it makes is apparently quite dramatic. One source mentioned a benchmark where an LLM's accuracy on answering questions jumped massively, like from 23% accuracy to 75%, just by giving it access to a web search tool.
Wow, okay, that's significant.
And the freshness matters too. Some platforms update their search index very quickly, like every 15 minutes, so the information is really current.
Okay, web search is a big one. What other kinds of tools?
Code execution. This is another really powerful capability. Agents can be given the ability to write and run computer code, usually Python, inside a secure, isolated environment.
A sandbox.
Yeah, exactly. A safe sandbox where the code can run calculations or analysis without messing with anything else.
So I could ask the agent to, I don't know, analyze the sales data and show me a trend chart, and it could actually write the Python code, run it, and generate the chart.
Precisely. It lets the agent perform complex calculations, data manipulations, statistical analysis, anything you can do with code, potentially.
Okay, that opens up a lot. Anything else?
Image generation is another tool mentioned.
Sure.
So the agent can create pictures or graphics based on prompts. Think of integrating something like DALL-E or Stable Diffusion directly into the agent's skill set.
So it could illustrate its own reports or generate creative visuals.
Potentially, yes.
Hmm.
And then there's document access. This is often done using a technique called retrieval augmented generation, or RAG.
RAG. Okay, what does that let the agent do?
It allows the agent to tap into specific documents or knowledge bases that you provide. Maybe PDFs, transcripts of meetings, company wikis, whatever. So its answers aren't just based on general knowledge, but grounded in your specific information.
Ah, okay. So I could have it answer questions based on a specific project report I upload.
Exactly. And the sources point at a really interesting side benefit here. Cost optimization.
How does accessing documents save money?
Well, think about having a long document, like a transcript of this entire conversation. Sending that whole thing to the LLM every single time you ask a question uses up a lot of processing power, measured in tokens, and that costs money.
Right, LLMs charge based on usage.
Yeah. So what Aurora does is clever. It first breaks the document down into smaller chunks. Then it creates a sort of numerical fingerprint and embedding for each chunk and also for your question. It finds the document chunks whose fingerprints are most similar to your question's fingerprint, meaning they're the most relevant.
Okay.
And then it only sends those few relevant chunks, along with your question, to the LLM.
Ah, so instead of the whole haystack, the LLM just gets the few relevant needles.
Yeah.
Much less data to process.
Exactly. Much more efficient and cheaper, especially when you're querying large amounts of information repeatedly.
Okay, that makes a lot of sense. So with persistent memory and this toolbox, web search, code, images, documents, a single agent starts to look pretty capable.
Very capable. But sometimes, the task is just too big or too complex for one agent alone, even with tools.
Right. And that leads us to more agents.
Pretty much. It leads to the concept of multi-agent orchestration.
Okay, orchestration, like conducting an orchestra.
That's a perfect analogy. The idea is that for really complex goals, you might have a main conductor agent that coordinates the work of several other more specialized agents.
So like a project manager delegating tasks to different team members.
Exactly like that. You could have a researcher agent that uses web search, a data analyst agent that uses code execution, maybe a writer agent that drafts summaries based on documents retrieved by another agent.
And the main agent manages the workflow.
Yeah, the orchestrator agent understands the overall objective and knows when to hand off tasks from one specialist agent to the next. It manages the flow, collects the results, maybe asks for revisions. It's building a kind of AI workforce.
And are the frameworks we talked about, like Mistral's, designed to help build these multi-agent systems too?
Yes, the sources indicate that these APIs are being built with this in mind, providing ways to define these workflows, manage the handoffs between agents, and enable this kind of dynamic collaboration.
Okay, this is getting pretty sophisticated. Agents with memory, tools, working in teams, which inevitably brings us to the responsibilities and the risks.
Absolutely. As these agents become more powerful, more autonomous, making decisions, taking actions, the ethical considerations become incredibly important. It's a recurring theme in the sources.
And they seem to cluster around a few key ideas. Fairness.
Fairness is a big one. The concern is that AI agents, especially those driven by LLMs trained on vast amounts of human data, can inherit and even amplify existing societal biases. Well, if the training data reflects historical discrimination, say, in hiring practices, loan approvals, even the way different groups are described in text, the agent might learn those bias patterns and apply them, leading to unfair or discriminatory outcomes. Imagine an agent screening resumes that learns to favor patterns predominantly found in one demographic group, just because that's what the historical data showed.
Right, so it's not intentionally malicious, but it replicates bias baked into the data.
Exactly. And mitigating that requires real effort, carefully curating and cleaning training data, consciously designing algorithms to promote fairness, regular audits, and importantly, having diverse teams building these systems to spot potential biases.
Okay, so fairness is crucial. What's next? Transparency.
Transparency and the related idea of explainability. This tackles the black box problem.
Right, not knowing why the AI made the decision it did.
Precisely. If an AI agent denies someone a loan, or recommends a certain medical action, or flags something in a legal review, the people affected and the regulators need to be able to understand the why. Why this decision and not another one.
It's about trust, isn't it? Hard to trust a decision you can't understand.
Totally. The sources call it a trust imperative. You wouldn't trust a doctor or a judge who couldn't explain their reasoning. So we need ways to make the agent's decision-making process more transparent.
And there are techniques for that.
Like XAI.
Yes, the field of explainable AI, XAI, focuses on developing methods to make AI decisions more interpretable. That might involve designing models that are inherently simpler to understand, or creating tools that can highlight the key factors influencing a particular outcome. Good documentation and ensuring there are ways for humans to oversee and question the AI are also key parts of this.
Okay. Fairness, transparency, and accountability.
Accountability. This is fundamental. If an AI agent causes harm or makes a significant error, who is responsible?
Not the agent itself, presumably.
Ah.
No. The strong consensus in the sources and in the broader discussion is that accountability must ultimately rest with humans. The developers who built the agent, the organizations that deployed it, the operators who oversee it, they are responsible for its actions and impacts.
And regulations are starting to reflect this.
Yes, you see things like the EU AI Act putting emphasis on risk assessment, on transparency requirements, on the need for human oversight, especially for high-risk AI systems. It's about creating frameworks to ensure these powerful tools are used responsibly and that there's recourse when things go wrong.
So those are the big ethical pillars, but there are other more practical challenges to actually getting these agents widely adopted and working well, right?
Oh, absolutely. Plenty of hurdles. One major one is just the sheer computational demand.
Right, these models are huge and complex.
Yeah, training these massive LLMs and running complex agent systems requires enormous amounts of processing power, which means significant energy consumption and cost. It's a barrier to entry and has environmental implications too.
Are there ways around that?
People working on it developing more energy-efficient models, techniques to compress models, optimizing the hardware, but it's an ongoing challenge. Then there's scalability and reliability. Getting an agent to work well in a controlled lab setting is one thing. Making sure it scales up to handle potentially millions of users and behaves reliably and predictably in all the messy, unexpected situations the real world throws at it. That's really hard.
And all this data they process. Privacy must be a concern.
Huge concern. Data privacy and security. Agents often need access to personal or sensitive information to do their jobs effectively. Protecting that data from breaches, misuse, and ensuring user privacy is absolutely critical. This involves strong encryption, access controls, and maybe techniques like federated learning, where the data stays local.
What about getting different agent systems to work together? If one company builds an agent and another builds a different one?
That highlights the challenge of interoperability. Right now, many AI systems exist in their own sort of silos. A lack of common standards makes it difficult for agents built on different platforms or by different organizations to communicate and collaborate smoothly.
Are people trying to fix that?
Yes, there are efforts to create open standards. One source mentioned something called the Model Context Protocol, or MCP, aimed at enabling better communication between different AI systems. But it's still early days.
And just managing all this within an organization.
That's the challenge of governance. How do companies, or even society, adapt existing rules and procedures to manage these agents? How do you define their roles, set boundaries, prevent unintended consequences, ensure they align with organizational goals and values? This often involves setting up internal AI ethics committees or review boards.
And one last one mentioned was digital sovereignty.
Yeah, this is more of a geopolitical or regional concern, particularly noted in places like Europe. It's the worry about becoming too dependent on critical AI technology developed and controlled elsewhere, which could impact technological independence, data control, and economic competitiveness.
Okay, so definitely not a straightforward path ahead. Lots of challenges to work through, technical, ethical, practical. But despite all that, where does this seem to be heading? What are the exciting trends?
Well, the sources point towards continued evolution in a few key directions. One is this idea of AI becoming even more agentic. So LLMs being specifically designed or fine-tuned not just to chat, but to be better planners, better reasoners, more proactive in driving towards goals.
So less passive, more take charge AI.
Kinda, yeah. More autonomous decision-making baked in. We'll also likely see continued improvements in persistent memory, allowing agents to build much richer, longer-term understanding of users and tasks.
Making them feel more like collaborators over time.
Exactly. And multimodal AI is a huge one. Agents that don't just deal with text, but can understand and generate images, audio, maybe even video.
So an agent could say, watch a presentation and then summarize the key points or answer questions about it.
That's the kind of capability multimodal AI unlocks. It vastly expands the range of information agents can work with and the tasks they can perform. Think about Meta, talking about Llama 3.2, handling visual and audio inputs.
Right.
And putting it all together, the overall trend seems to be towards more autonomous agents being adopted across industries, handling increasingly complex tasks with less direct human supervision, from optimizing logistics to driving scientific discovery.
Okay, so let's try and wrap this up. We started by talking about the shift from AI as just an information source to AI as an active participant, the difference between an assistant and an agent.
Right, and how this shift is driven by merging the doing capabilities of agents with the understanding power of LLMs.
We saw how this is already being applied in areas like law, healthcare, finance, automating tasks, improving efficiency.
And we looked under the hood at how it works. That perception planning action loop, boosted by frameworks offering persistent memory, and crucially, those powerful tools like web search, code execution, image generation, and document access through OG.
We also touched on how RAG can make things more efficient cost-wise, and how agents can even team up using orchestration for really complex jobs.
But then we had to address the flip side, the critical need for fairness to avoid bias, transparency so we can understand decisions, and clear accountability resting with humans.
Alongside the big practical challenges, the sheer compute power needed, making these systems reliable and scalable, protecting privacy, getting different systems to work together, and governing their use responsibly.
It's definitely a complex picture. But the core takeaway is this move towards AI that can act autonomously based on understanding language and context, equipped with tools to interact with the world. It's really changing the game.
It really is. It feels like we're moving beyond AI you just talked to, towards AI you can collaborate with on actual tasks.
Which leaves us with a pretty interesting thought, doesn't it? As these agents get better at acting, using tools, maybe even coordinating amongst themselves, what new ways of working alongside AI will emerge?
Yeah, how might your day-to-day work, your personal tasks, fundamentally change when the AI you interact with can not only understand what you need, but can actually go off and do it for you? That's definitely something to ponder.
Yeah.